Hello students, this is supplementary video. Here we will talk about the nature of magnetic field around current carrying conductor. So if we have straight wire and if we are asked to decide what is the direction of magnetic field around the straight wire or maybe current carrying ring, how do we know that at given point what is the direction of magnetic field? So that is what we will try to understand in this video. Let us first consider straight wire. And now I have 2 points. Say one point is here and other one is below the wire. Let the upper one be A point and lower one be point B. So if you keep your right hand thumb in the direction of current and if you let your fingers curl around the wire, you will realize that the curling will be like this. So if you draw a ring at point A, the tangent or the fingers will be coming out, whereas at lower point B, the fingers would be going in. So I can say that magnetic field at point A is B K cap. Magnetic field lines are coming out, whereas magnetic field at point B is going inside, so it is minus B K cap. Right? And what if I consider one point, say C in front part of the wire, D at back part of the wire, then we can say that at C point, magnetic field at C point. Now look at the tangent. At C point, fingers would be going down, so it is minus B J cap. At D point, if you draw tangent, it would be going up. So at D point, it is plus B J cap. Okay, so let us consider a few more cases. Consider current to be going like this, and now again I have points. Say one point is here, other one is here, other one is here, and fourth one is at bottom part. So let us again name them as A, B, C, D. So how do I know what is the direction of current for all this? Here current is in negative x direction. Okay, and I want to determine the direction of magnetic field at point A, point B, point C, and D. So what you have to do is again place right hand thumb along the current. So place right hand thumb in this direction and curl your fingers around the wire, and then you will realize that your fingers at A point are going inside, fingers at D point are going down, fingers at C point are coming out, fingers at B point are going up. So at A point, when I am talking about, if tangent is going inside, it is the direction of z-axis, negative z-axis. So it is B A K cap. At B point, what is happening? Look at B point. Tangent is going up, and then upward direction. Can I say it is J cap? Then magnetic field at B point is J cap. Then what about C point? Look at C point. This is actually direction coming out, that is positive z direction, and then it is B C K cap with plus sign, and at D point what is happening? Negative y direction. So D J cap with negative sign. Of course, if the distances are same for ABCD, you don't need to write BA, BB, BC, and BD. Why? Because the intensity will be same, right? So this is how we can determine magnetic field of straight wire at different points around it. Okay, and what if we are talking about current carrying ring? Now it is very interesting to visualize the nature of magnetic field for current carrying ring. Suppose the current is passing through a circular ring. So if this is the current and if I have to determine magnetic field, how do we know? So at P point, or let it be point A, and consider one more point, say B. So I want to know magnetic field direction at A point, magnetic field direction at B point. What should I do? So the rule says that use right hand screw. So place right hand screw perpendicular to the loop and then rotate it. How should I rotate it? In the direction of current. What is the direction of current? For now, this is the direction of current. Okay. And then you will see that screw will be advancing in this direction. So magnetic field of this ring at point A is going like this. At point B, it is going like this. But even if you consider small part of the ring, it will have its own magnetic field. So it's not along axis. Overall, you have magnetic field lines going like this. See, this is the nature of magnetic field lines of a single ring. Okay, and it is earlier in one of the videos I had explained that single ring itself is like magnet. Suppose if you have bar magnet and if you look at the nature of magnetic field lines of bar nature, suppose this is north pole, other one is south pole, then the magnetic field lines come out of north, isn't it? And field lines enter into south pole. So this is the nature of magnetic field of bar magnet, and current carrying ring behaves in very similar manner. Here also magnetic field lines are going like this. So the way we had electric dipole moment, we will have magnetic dipole moment. We'll talk about it at greater length in the forthcoming topics. But this is just to give you analogy between bar magnet and current carrying ring. Both are having very similar nature of their magnetic field. So that is all about nature of magnetic field of ring and magnetic field of straight current carrying wire. Now, what if we take two rings? Suppose one ring is having its current flowing like this, and then, as I explained, its magnetic field would be going like this. This is the nature of its magnetic field lines. Now, I want to place another ring close to it. Say, here is my second ring carrying current, similar current, and radius is also similar, so field lines would be very much similar, just like first ring. But what if we place these two rings close to each other? What will happen then? What if I have 10 such rings? What will happen in that case? So now when you have individual rings, see, this is how field lines bend. Along the axis, field line is straight, but as you go towards the wire, as you go away from the center, field lines bend. So when you have many rings, suppose if I take first ring, second ring, third, fourth, fifth, and if all are carrying same current in same manner, then overall the magnetic field line coming out from the first one will not bend. Unlike this, the field line will not bend, rather it will enter into next. It will enter into next, it will enter into next, and then it will bend. Okay, so this is how field lines will go out when you take so many rings, and that is the solenoid. Solenoid is nothing but collection of so many rings, helical winding of current carrying wires. So in case of solenoid, this is how we have magnetic field lines. So if you take, suppose if I take smaller solenoid, consider two solenoids. Say this is first solenoid, and consider a longer solenoid. What is the difference between magnetic field lines? In case of first solenoid where length is less, this is the nature of magnetic field lines. Okay, whereas in case of second, the bending will be slightly less because length is more. So it's not that field lines will not bend, but in middle region, the field lines are almost equidistant and parallel. So uniformity of field increases when you consider magnetic field lines inside the solenoid. And in this region, as we go to the end of solenoid, the distance between the field lines change. So we say that non-uniformity increases, but in middle part, field lines are almost parallel. And then we can say that field lines are parallel, so magnetic field is uniform inside the solenoid. So this is what we should be knowing about magnetic field. Now for straight wire, again let me consider few cases. We did consider these two cases. Suppose I have case 1, case 2. In first case, if I have point A, point B, what is the magnetic field direction at A point? So as I explained earlier, place right hand thumb along the current direction, and then at A point fingers will be coming out. So what is the direction of magnetic field? K cap. Okay. At B point, fingers will be going in, and hence it is minus B K cap. But what if I consider current in opposite direction, and again if I consider the same 2 points A and B, now if you place your right hand thumb uh, along the current, you will realize that at A point fingers are going in, and at B point fingers are coming out, and hence at A point magnetic field is along negative x-axis, whereas at B point it is along positive x-axis. What if I consider this case? What is this case? Or else say this one. What I'm talking about? I am talking about a condition where wire is placed in such a way that it is coming out of plane of this page or screen. What is dot indicating? Dot is indicating that the quantity is coming out. So current is coming out towards our face from this screen. And what is happening here? Current is going inside. So keep your pen in such a way that it is perpendicular to the screen, and then consider 2 points. Consider one point here on left side of the wire, consider one point here on the right side of the wire. So now if you keep your thumb towards your face, because see current is coming out, so place your right hand thumb in such a way that it is coming out of the screen, and then look at the curling of your fingers. You will realize that curling is like this. So what is the nature of magnetic field at A point? What is the nature of magnetic field at B point? So you realize that at A point magnetic field lines are going inside, fingers are going down, so magnetic field lines are going down, not inside, sorry. That is negative y direction, and at B point it is positive y direction. Similarly, in the right side figure, if I consider 2 points, again say A and B, and now if I am asked to find out direction of magnetic field at A point, what should I do? Now here again keep your pen in such a way that it is perpendicular to the screen, and keep your thumb along the pen but as if it is going inside the screen. And look at the curling of your fingers around the pen. You will realize that fingers are going like this. So now, if I am asked to determine the direction of magnetic field at A point or at B point, uh, what is the direction at A point? Field line is going up or fingers are going up, so magnetic field is in positive y direction. At B point, field line is going down, so negative y direction. So this is how we can determine direction of magnetic field for different orientations of straight wire and for ring. Please watch this video twice or thrice if you are not clear. This is a very important topic for conceptual understanding. I hope you could understand. Thank you.